Hello, everyone. This is Team 34. Our project is about the application of neural network on predicting financial time series data. Before coming to the target of this project, I'd like to introduce some basic knowledge to you. That is about how the price is decided in the stock market. There are two different roles in the market: the seller who want to sell the stock and the buyer who want to buy the stock from the market. The upper left figure shows how they interact with each other. The x-axis represents the price. From left to right is corresponding to low to high. The blue ones are buyers and the yellow ones are sellers. The number of blocks is the total volume on the price. When these blocks are taken by the opposite players, they vanish and the edge moves. There are also some definitions here. The mid price is average of the best ask price, best bid price. The input data includes the price and volume data, which is a 100 by 40 matrix. And the target is a prediction on the trend of the mid price. So why is it important to predict the mid price? The first reason is that it can help us make some profit from the market. And secondly, it can give us some guidance for market makers. And besides, in this project, we use IFI 2010 data set, which is often used by similar tasks.
Okay, let me briefly tell you guys the historical approach and the current approach we used. So historical, people used ridge regression, LDA, and LSTM. The main drawback of those methods is they directly use those methods without using any kind of feature extractors. And so it's natural to use some feature extractors. In one of the most recent work, the author adapted a so-called deep libel model where they use the CNN as a feature extractor. And it's really natural for us to adapt what we have learned in the class, like the transformer instead of LSTM. Next slide, please. So I will give you guys like a detailed introduction about architecture of our model. First, you have your input, and then you feed your input into a convolutional neural net, which consists of 3 blocks. And in different blocks, we are using different size of the kernels here. And then after the CNN model, CNN block will feed the output into the inception block. And the reason why we want to use the interception block is that, as you can see here, the interception block, we are using 2 different kernel sizes, 3x1 and 5x1, which allows to capture both short horizon signal and long horizon signal. In addition to that, we also use a max pooling, which will be able to capture the nonlinear structure of the data. Next slide, please. After the feature extractor, we are able to feed the output from the feature extractor into the transform block. So basically, a transformer block consists of 3 parts. The first part is a transformer encoder, and then followed by a LSTM block, and then end with a transformer decoder blocks. Then we will finally get a probability distribution of 3 class as designed.
As we can see from this slide, actually for all of these 3 time priced labels, our model is not as good as the original one in terms of the accuracy. Specifically, although we are also yet to reach the original result by implementing their model, the differences are all negative for this stage. In conclusion, as we re-implement the baseline model, we found the result there is not quite stable, which means the prediction accuracy varies when we re-implement the deep LLB model. This might comes from the lower learning rate they used in the paper, which we adopted as well. A significant low learning rate might make training be more likely trapped to local optimal. Thus, nature's thing was to try in the future is by modifying the loss function or the optimizer. We have seen a slightly lower accuracy of our results from the baseline model, which suggests that the transformer architecture might not be as promising in the highly noisy financial time series data. And potential work to improve is by trying different feature generator, because for this stage, we just adopted the same CNN-based feature generator as the one from the paper. That's all of my presentation. Thank you for listening, and we look forward to your feedback.